All right, so we're gonna just, let me make this full size. So we're going to, again, walk through the iron chloride test, and that is a test for leftover salicylic acid. And then we're going to look at the pH test to determine the acidity, and then the melting point. And it's all in the same video. All right, so let's do that now. So let me hit play, and of course I'll interrupt and give feedback in between. Hold up, let me turn this up.
The numbers underneath there, they kind of got washed out. So we're gonna add some salicylic, some iron chloride, each one of those.
So this is the addition of iron 3 chloride, which is a iron salt with chlorine. And what it does is, and I think I know this is in the video, but it'll form a complex with any leftover salicylic acid. It'll bind to that carboxylic acid, oxygen, and the hydroxyl group on the that's adjacent to that carboxylic acid on the ring. All right. And when that complex forms, it turns purple. So if it turns a dark purple, you got a problem, because that means that your aspirin is really impure with a lot of salicylic acid left over. If it's faint purple or no color change, then that's good. That means your aspirin is very pure.
First to the group, because I want to see what happens. And I only need a couple drops. It's crude aspirin. That's the aspirin before we purify. See how purple it is?
So you can see right there with the crude, it's very dark, right? What that means is that crude aspirin, you expect it to be dark because it's crude. So that means you've synthesized it, but you haven't recrystallized it. So what that means is that there's lots of salicylic acid left over, probably a little bit of acetic anhydride left over, definitely some acetic acid left. And so you expect that to look that way.
So now we know what we don't want to see. So I'm going to add this same iron chloride. I'm going to add a drop to pure salicylic acid and see what happens there. Hopefully you can still see that. We're going to add 1 drop, 1 or 2 drops. Just pure salicylic acid. You can see right away how dark it is. Right? And that's what you expect. In the video, it said that the iron chloride forms like a complex with salicylic acid and it turns purple. So you can see that. Y'all see that? So the plain pure salicylic acid also turns deep purple.
Now you can see that's even darker than the crude sample, because this is just a solution of salicylic acid just dissolved up in, if I'm not mistaken, in ethanol. All right, you expect that.
What you don't want is for your aspirin sample to look that color. You want it to be lighter than that. The lighter it is, the less salicylic acid is left over after you purify it. So let's see what this is sample 11. You can see.
Okay, so I think there are 3 samples here. So again, you'll be able to pick which data you want to use. So sample 1, 2, and 3. And then you can, on that data sheet where it says iron chloride test, you can put deep purple, light purple, or whatever you observe.
Immediately, that first sample 11 on the end, can y'all see that?
So this will be, if you're tracking with sample 1 from the first time that we started the experiment, then this will be your sample 1. You can see it's very faint. That's a really pure sample right there. You expect a little bit of salicylic acid left over, but not a lot to make it turn dark, but that's a really clean sample. So if you're tracking with sample 1 in the data sheet, you'll just write in faint purple, or you can put very faint purple.
Right, it didn't turn purple at all. It turned like a very faint purple, which is good. That means it's very pure. If it was dark purple like the other 30 on the left, second row on the left, compared to the last.
Right, so this will be the second sample. And you can see it's a little bit darker, but it's still pretty faint compared to the crude, which is good, but it's a little darker. So you can, if you're tracking with that sample 2, then you can write down that observation.
As well at the top right, 30 is a little bit darker than 11. So that means that it's a little bit less pure, but it's still not bad because it's faint. The purple is still faint, so that's good. All right. It's darker than the other. Can y'all see that? See the difference? How 11 is like really like faint, and then 30 is a little darker, and then 106 is very dark compared to both those. Y'all see that? So this is 106 here.
Yeah, so you can see that purple compared to the other two is much darker, right? It's almost not quite, but it's almost as dark as the crude, which is horrible, right? This was a really bad sample. So this would be sample 3. And I know if you're tracking with sample 3, that's fine. You don't get penalized for how dark the color is or something like that. You just making an observation.
And this is 30, and this is 11. You can see 11 out of those 3 samples. 11 is the purest out of all of them. All right. Any questions about the purple color test part?
So now we're just taking the aspirin and testing the pH. We expect aspirin to be acidic because of the carboxylic acid moiety that's present, that functional group that's present. While we have acylated the alcohol, the carboxylic acid is still there, right? So we expect that to be an acidic functional group.
The color code for the pH. All right, so we're gonna use that. We're gonna dissolve these samples up in ethanol just like we did the last one, and then we're gonna use this guide to kind of help us determine what the pH is. If it's the darker red it is, the more acidic. As it turns from red to green, neutral, and green to blue is basic. But you don't expect it to be basic, right? Because there's a free carboxylic acid in that aspirin molecule. So you expect it to be somewhat acidic. So let's find out. Just like that. And they're just going to dip it into where that sample is and read it. And you want to read it immediately. You don't want it to sit because this paper is air sensitive, water sensitive. So it might start out red. You come back in 10 minutes, it's blue. So you want to read it right away. And then just record on your paper what your pH is. And then whatever you got for 11, that's what we're going to put in the chat. So you get for 30, we'll put that in the chat. For 106, we'll put that in the chat. Y'all, we can work with off those values.
But there's the whole thing in it.
Just the tip, just the edge of it.
Orange.
Didn't change much, did it? So where are we? So it's orange, kind of right there about 4. Let me see. Let me show them. So they.
All right. So sample 1, if that's your sample that you're tracking and have been tracking, your pH value is going to be 4.
You know. So this is the pH meter or the pH guide, and this is the strip after she dipped it. So it looks like it's close to about 4, which is expected. Somewhere between 3 and 4. You expect that. Because again, on aspirin, you got this free carboxylic acid that is acidic. I mean, those proton is transferable. So go ahead, group. About the same, about 3 or 4. Same for that one.
All right. So sample 2, same pH of 4. If you're tracking that sample, then you can write that on your data sheet.
And again, this is the guide right here, so we can match it up. Yeah, about the same. So we're looking at each one of the samples having a pH ranging from 3 to 4. So it doesn't matter which one you pick. 30, 11, 106, doesn't matter. They all have a pH of about 3 to 4.
All right, so the last part of this walkthrough is dealing with the melting point. So I sent you a video about how to conduct a melting point experiment. And we use what's called a very simple instrument called a melt temp. And it's basically just a heating element that you can control with a transformer. And you have a thermometer. And then within the melt temp, there are some slots to put a capillary tube in full of your sample. It's that simple. The melting point, the thing about the melting point, and you should write this down, that it's not a point, it's actually a range, right? So the melting point it's where the material starts to melt, so you can see it start to liquefy, and then where it stops melting, which means that it's all the way liquefied. In between those two temperatures, that's your melting range. So the start temperature and the final temperature. So your melting point is actually a range of temperatures. Let's say if it started melting at 55 degrees and it stopped at 58, that means that everything in that capillary tube has been liquefied. And when you're asked for the melting point, you'll report 55 to 58 degrees Celsius or whatever your temperature unit is.
The melting point with is this instrument right here. It's called a melt temp, right? And so the way we use the melt temp is very simple. First, we gotta plug it up, obviously, because it's electric. And then after that, what we want to do, the way you measure the melting point, if you watch that melting point video, hopefully you did, you ramp the temperature up until you get about 20 degrees away from your melting. Who looked up the melting point for aspirin? That's Fahrenheit. So about 135 Celsius, right?
Right. So in your handout, I can't remember if there's a table for the melting point, but you can write it on the back, or if you're in the actual digital document, you can just go to the next page and type this in. But the melting point for aspirin is 135 degrees Celsius, right? That's the reported melting point for pure aspirin. And so with the melt temp, what you're measuring is how your aspirin stacks up to that. The closer it is to that, the more pure it is. The further away from that it is, then that means it has some impurities in it and it's kind of junky. All right.
Okay, so we're expecting 135. So we're gonna wrap up the melt temp using this little dial right here. It's very rudimentary. We're gonna turn that dial to about 4, somewhere about 4 or 5. Don't do it yet because you'll have your sampling. And then when the temperature gets to about 115, we're gonna turn it down to about 3.5. And that way it'll slow down the temperature increase. Because once you get to about 20 degrees out, you want to increase the temperature about 2 degrees per minute. This is very tedious and time consuming. So we got 3 melting point capillaries, and we're going to put some sample into these. I'm going to take one of them and put some crude in it for each one of you. So you're going to measure your pure stuff against the crude. You expect the crude, you see that the crude, how dark purple it turns crap. So it's not going to melt at 135. It should melt way before that because it's full of crap. The more pure it is, the closer it's going to be to that 135 expected temperature that you looked up. All right. So we're going to take some sample, and I'm going to show you this. Normally, you have a tube that you can drop your melting point capillary down in and get the aspirin to settle. What you don't want to do is jam it into the aspirin, because if it gets stuffed, it's not going to go down. So let me show you what to do first, and then take it from there. Man, this thing needs to turn down. All right, so that's my crude aspirin. I'm going to take my capillary, and I'm just going to dip it in here on the open end, not the closed end. Just going to dip it in. You can see I got aspirin in the tip. Can y'all see that at home for your viewing pleasure? Just tap it on the bench top, just like that. And you just keep tapping in until you can see a little bit of the aspirin has gone down, but not all of it. So you just keep tapping until you get it to the bottom. You want to have it about 1 centimeter, maybe a half a centimeter from the bottom. That way, when you put it into the melt temp, you can actually see. That's the purpose for the amount. Right, so y'all see how that got to the bottom? Just by a little finesse and a little tapping. That's what we're gonna do. So I'm gonna put a little bit more in here because that's not quite enough. And again, you don't want to jam it because if you do, then it's gonna get stuck at the top and it won't move. That little circle can y'all see that? Inside of that,
Yeah.
just like
And so inside the melt temp, you can see there like these little slots. And once you get your sample loaded into the capillary tube, you sit the sample into a slot. Each melt temp has 3 slots. And then there's a magnifying glass here, so you can actually view your sample and see when it starts to melt and when it's done melting.
you see those little grooves in the melt temp. So you kind of ramp the temperature up and you look through that viewfinder to see if your sample is melting. It's very important when you're doing a melting point to write down the initial temperature
Yes.
when your sample starts to melt, right? So if it starts melting at 120 and it stops at 128, that's what you record as your melting point, right? Because it's really a range and not really a point. So there's a range of temperatures that your aspirin is going to melt over, and not just a single point. Can y'all see that sample, that tube that's in there? Can you lift up on that a little bit just to see if we can see it? I can see it moving in the cameras. Yeah, there you go. Can y'all see that?
Yeah.
Okay, that's one sample. So we're going to load the other 2 samples in, and then we're going to ramp that temperature up, and when it starts melting, we're going to ramp the temperature down and slow the heating down so we can get a good, accurate melting point. So this is like watching paint dry.
That part about the temperature is very important. If you ramp the temperature up and leave it, then you're not going to get an accurate melting point. Your stuff is going to melt, no doubt about that, but it's going to be really inaccurate because the melt temp is going to be so hot that you're not going to be able to determine what that initial temperature is. So it's really important you find out the melting point of your compound, whatever the actual compound is, and then you can adjust the melt temp so that it increases by a certain number of degrees per minute. There's a chart that you can use to determine, to make the temperature go up by 10 degrees per minute or 5 or 2 degrees per minute. It just depends. But it's really important not to just jack up the temperature and walk away and come back, because you won't have any idea like when it started melting. You'll just see it melted and you won't have an accurate temperature.
But I'm gonna try to get another shot of all 3. Y'all can see that she has all 3 of her samples loaded. So you can see right here, that was a solid, and now it's kind of, let me see. And now it's fully liquefied, so that's what you're looking for through that viewfinder. And the crude for 11 was started at 110 and ended at 115.
So if you're tracking sample 1, you can write those 2 melting points down, 110 to 115 for crude. Sample 1. And I'll put it in the chat.
That's about 20 degrees off the expected melting point for aspirin. Let me see if I can let y'all see this. I don't know if I'll be able to see that, but everything in there should be, come on camera, liquefied. Can y'all see that?
So this is the pure melting point for sample 1, 134 to 136. And I think the other melting points are reported. Yeah, sample 2, if you're tracking on that, the pure melting point. So the crude was a generic sample. So you can put, so whether you use sample 1, 2, or 3, your crude is going to be what I put in the chat. I think it's 110 to 115. And then your pure sample is going to be for sample 1, let me go back, 134 to 136 for the pure aspirin. And then for sample 2, 130 to 135. So all these are very pretty pure. And then sample 3 is, oh, let me go back.
Should be
Sample 3 was 120 to 128. All right, so depending on which sample you're tracking. So sample 3 is 120 to 128. 2 was 134 to 136. Oh, 130 to 135. My bad. Sample 2, 130 to 135. This is in Celsius, and then sample 1 was 130, 34, 136. Let's see, let me double check. Yes. And this is for the pure aspirin. For crude, you can use the same temperature for all 3 samples, which was 110 to 115. All right, questions about the melting point, questions about iron chloride testing, questions about the pH, or about anything.
Yes, I have a question.
Go right ahead.
Just to repeat what you said earlier about the crude, it's gonna be 110 to 115
Yes.
for trial 1, right?
Yeah, it's only one trial. So you can just fill in trial 1 and then you can line through trial 2. Yeah, great question.
Thank you.
And it's the same for all of them. Since there was only one trial for each one, you don't have to worry about the second trial. No, under normal circumstances, we do 2 trials just to get an accurate average of the melting point. But in this case, one trial will suffice. We'll be fine with that.
I had a question about midterms.
Go ahead.
When will our midterms be? I know that the dates are the 11th and the 12th, so will it be next Tuesday during class time or?
Yeah. Yeah, it'll be during class time. It'll be online, just like, and it's open. And I'll leave it open. I will probably open it on Monday and leave it open through Wednesday, since I have a lab on Tuesday and Wednesday. And so you'll have between Monday and Wednesday to complete it.
Okay, sounds good. And I
Mhm.
also had another question, but I wanted to ask that after class.
Okay, or you can put it in the chat. You can just send a direct message.
Okay, I'll do that.
Yeah. Other questions, anybody? I actually reached out to the contractors this morning to see what the holdup is with 313 and 300. So hopefully they email back. I've been in meetings all day and unable to check my email, but hopefully they've responded back. I think what we're going to do for sure, though, is the next 2 experiments. One of them, which is infrared, and the other is NMR. We're going to actually do that in person. It can't be everybody because of the COVID restrictions on room occupants and all that, but I'll send out a survey or something, and then we may do NMR for 2 weeks. That way, anybody who wants to come will have a chance to come, and that'll cover everybody. Or we may have to extend it over 3 weeks, so we'll just do the same experiment more than once. But I want you to at least get some hands-on experience. I mean, I'm telling you, this is killing me to be doing it this way as opposed to actually being in lab. But so yeah, the NMR and the infrared we're going to do in person, and we do both on the same day, because the infrared doesn't take very long to run. That experiment is actually a fairly quick experiment. So yeah. All right, any other questions?
Dr. Russell, I
Go
do
ahead.
have a question. The last question that I had was about the pH.
Uh-huh.
I know you said that there might be a place to put that on the worksheet. I'm just writing it down. Can you also tell me what that was?
Oh, the value for each sample was 4. So
4.
sample 1, 2, and 3 all had a pH of 4.
Okay, thank you.
Yeah, you're welcome.
Professor Russell, are you gonna drop the recording on Blackboard or something?
This one?
Yes, sir.
Yeah, I'll upload it. Ooh, I should not be recording all this stuff. But yeah, I'm gonna upload it to YouTube.